Hi friends. So in this lecture, we are going to learn about the RDBMS design for ER diagram. So given that here is an ER diagram model, and let's say we have to convert it to the RDBMS design. Okay. So for that, definitely we need to convert it into minimum RDBMS table design, right? So here, if you see, we have these entity set E1, E2, E3, E4 and some relationship set along with the attributes, okay? And also we are given some constraints like we have this MS to N mapping, okay? We have this 1 is to M mapping. We have this 1 is to 1 mapping with total participation at this end. Okay, again we have here let's say this is this. Okay, so we have M is to 1 mapping here, and then we have 1 is to 1 mapping, okay, with partial participation at both ends. So if we have to categorize group them as the RDBMS table, first of all let's see this MS to M mapping. Definitely for these three we need three relation. So this will be grouped separately, this will be grouped separately, this will be grouped separately. So we have one table R5 with attributes as A and G, and this is the candidate key for R5 with A as a foreign key and G as foreign key. Okay, because A will be pointing to this candidate key and G will be pointing to this candidate key. Okay, so here we have two foreign key plus one candidate key or a primary key you can say, and this is one table. Okay, let's see next. Here you see that it is 1 is to 1 mapping and there is a total participation at one end. So definitely we can group them as a single, okay, single set. Okay. Also, if you see here, this is M is to 1 is to M mapping. So this E, one value of G is configured to many values of E. So R4 can be grouped with E3, right? So this could be taken as together into one table, that is even R1, E3 and R4. Just a second. Okay, R4 with attributes as A, B, then we have E, F, and then we have here it is E and G will be the attributes of which E will be the candidate key. So E and here G. So for this E and G will be the attribute, and G here is a foreign key for this. So there will be definitely one foreign key that will be G. Okay, and of course we have these all attributes here. So A will be the candidate key and E will be the candidate key for this. Okay, so A and E will be the candidate key here. Okay, just a second, let it be clearer a bit. So okay, it's G, and one foreign key will be there plus two candidate. Okay, similarly if we have this is left. Okay, so this is 1 is to M mapping. Of course R2 can be grouped with E2, and this is 1 is to 1 mapping, so we can have R3 covered up with E2 as well, because these can be classified into two tables. So let's take R3 with E2. So if we map these all together as one, okay, so definitely we are left with this table only. Okay, so if we see, we have one table as this one, R2, E2 and R3. So R2, E2 and R3, and the attributes would be, from here we have A, C, D and G. So A, C, D and G, of course. So G is there, and then we have a C as there. Okay, and A, C, out of A and C will be the candidate key here, and out of D and G will be the candidate key, and also G will be the foreign key referring to this candidate key. So one foreign key is there, that is G. Okay, and two candidate key. Okay, so this will be one table. And now let's say we have this E4 left. So E4 will be separately grouped as one table with G and H as the key. So one candidate key. And if you say this will be the foreign key for this one particular. So one FK, right? So here, if we say we have a minimum RDBMS table equal to 4. Total number of attributes, if you ask, that will be here we can count like we have 2 attributes, then we have 5 attributes, that is 7, then 4, 11, and of course if we take 11 plus 2, 13. Okay, so altogether 13 attributes and 4 tables. If you ask number of foreign keys, so let's see the foreign keys. What are these? So definitely here A and G. So A will be the foreign key for one, and G will be the one. Here, if we say these entire relations, so in this we need to have, for this there will be a foreign key, that is G will be pointing to this one. Okay, so this will be one foreign key. And altogether here we don't need to worry of anything. So definitely all these are the attributes only, these are taken into one part. And so there will be one foreign key here, there will be 2 foreign key here, 3, and then if you see for this particular relation, then we have 1 foreign key here and 1 foreign key here, that is 3 plus 2, 5. Okay, so for E4 we don't have, I'm sorry, there won't be any foreign key, but here we need to have 2 foreign key for this particular relationship. So there will be 2 foreign key. Okay, so this C, if you say this one, so C will be 1 foreign key. So sorry, there will be for this we will having A and C, so A will be 1 foreign key pointing to this particular, and for this if we say we have C and G, so G will be the foreign key pointing to this. So 2 foreign key for this set. So we have 2 foreign key, then we have 1 foreign key here and 2 foreign key here. So altogether the number of foreign key, if you ask, is 5. So this way we can find out the number of foreign key, minimum number of RDBMS table, and total number of attributes altogether, and so forth. So the basic funda is here that we need to consider of the constraints, and the 2 types of constraint, that is the cardinality constraint and the participation constraint, and how we can group the entities and relationship set into one table so that the integrity is maintained, that is the RDBMS design model is maintained. Okay, we are going to see some more examples in the upcoming lectures where we'll learn about the self-referential entity set model, and also about the weak entity set, and so on. so forth. So let's end this video here, and please do keep watching, and thanks for watching for this video. Thank you very much. Bye bye.